Last time we defined composition of functions. We said if we had two functions f and g, we could say g composed of f of x is the function g with f plugged inside it. And we also discussed the domain of g composed of f. We said the domain is the set of all x in the domain of f, such that f of x is in the domain of g. And we looked at one problem, and we're going to look at more problems. I also want to show you the picture again, just as a recap of what happens. Let me zoom out a little bit. So we start with a domain of f and a range of f. So A is being sent to B through f. Then we have g, a different function. G has a domain and a range. And what we're doing when we're saying g composed of f down here, this g composed of f, what's happening is we're looking at elements in A that are sent to elements in B that intersect with this B prime. And then we're finding where they're sent in the set C here. So this portion here, so we had maybe like these elements are sent to this portion here, and then those elements are sent here. And so G composed of F is like skipping this middle step. We're taking these three elements and sending them here, rather than going from here to here and then to here. Something else I want to mention is we can also talk about not only G composed of F, but we could say F composed of G, or F composed of F, or G composed of G. So let me write that information right here. So we can talk about not only G composed of F of X, which we have defined here. This is G with F of X plugged in, but we can also say things like F composed of G of X, and that is F with G plugged in. So what I want to tell you, and this is how you're going to read this, is when you see this, you always start with the rightmost function. You see how I have F here? F is inside. And let me just make some more room here. So when I see this one here, this F composed of G, this G here is inside. So we start with the rightmost function, and then we work our way to the left. We have something like F composed of F of X. And what that means is when we have F composed of F of X, we're plugging F inside this F inside F. And then we could talk about G composed of G of X, which is G with G plugged inside. We can even talk about more functions. So if we had something like, let's say we had the functions f, g, and h, then we could talk about f composed of g composed of h, things like that. Now, we're not going to go that far in this class, but it's something we could do. And what I mentioned about reading it from right to left, what the definition of this would be is we start with H, then we go to G, and then we go to F. So this is equal to F with G with H plugged in. So you see you have H, you start with that, and what you would do is you would plug it into G, and then you would plug that into F. So that's just the idea of what's happening here. So we're going to look at some examples. And we're going to start, we're not going to focus so much on the domain this time. In the next video, we'll talk more about the domain. This time, I just want to give you some basic examples. So here is our second example, the first example I gave you in the last video. So in example 2, I'm giving you a chart, and I want you to find parts A through F. So let's look at this chart. I'm going to zoom in a little bit. So let me tell you what's happening in this chart. I'm giving you some X values. And then underneath it, for each one of these X values, I'm telling you where F and G are sending those X values. What I want to find is these 6 different letters here. I want to find f composed of g of 1, g composed of f of 2, f composed of g of 2, and so on. You can see I have all of these. And what you should do is you should take a minute and just jot all of this information down. So make a chart with this stuff, and then put these 6 letters off to the side. Maybe watch me do a couple, and then try to do them on your own. So pause the video after you see me work through some of them and see if you can figure out the rest, and then just check and see if you got the same answer. So here I have X, and let me write some information down here so we can understand this chart. So let's focus on what's happening here, just so we understand what's happening. You see that I have X is -3, and underneath it, I have f of -3 is equal to 11. So what this means is for this X value, -3, if I plug it into the function, I'm being sent to 11. And down here, this is saying when I plug in -3 into the function g, I'm being sent to -8. So you can continue this. You could say when I plug in -2 into f, I get 9. And when I plug in -2 into g, I get -3, and so on. So you can see the domain of f and g are the same, at least for this for these numbers here. You can see that the domain of f is -3, -2, -1, 0, 1, 2, and 3, because we're getting values here in the range. Remember what a function does? It takes domain values, so we're taking this like -3, and we're sending it to 11 through the function f. So we have the point -3, 11. If we wanted to graph it, this would be a point on that function, on the graph of that function. And the same thing here with g. We are taking -3 and sending it to -8, and -2 sending it to -3. So this is our domain for g, and this is our range for g. Okay, now let's focus on this piece over here. I'm just going to start with part A, which is f composed of g of 1. And let's see if we actually understand this definition. Now remember what I put at the beginning of this video? We said that this is equal to f of g of 1. So we start with the right and we make our way to the left. So we start with this one and then go this way. So what I'm going to do is I'm going to take the value 1, look for it in the domain, which here is 1. And then I'm going to plug it into the rightmost function, which is g, and I get 0. So this is equal to f of, well, g of 1 is 0. So then what I'm going to do is now I'm taking this number, which is a number in the domain. So remember that what I see here is I'm looking for what the value of f is when I plug 0 in. So when I plug in 0 into f, which is right here, I get 5. So this is equal to 5. So let's just recap really quickly. So we started with 1, which is right here. 1 was sent to 0, and then 0 was sent to 5. Okay, let's try part B. For part B, notice that I flipped. No, actually, I'm looking down here. I should be looking this side. B is f composed of g. So we're sticking with the same order of functions. F composed of g of 2. Let's see if we can figure that one out. So we start with the number 2. I like to write it this way. F with g of 2 inside, because this, to me, this is less confusing than this side here. So what I'm going to do is I'm going to search for the value of g when we plug 2 in. So I'm going to circle 2, and when I plug it into g, I get -3. So let's put -3 here. I don't like to do this all in one step because I can make a mistake easily, because you wouldn't have to write all of this down. But like I said, you can make a mistake. So f of -3, well, I search for -3, and then I plug that into my function f. Here's f. So I want to look at f's values, and I get 11. So f composed of g of 2 is equal to 11. And what I meant by when I write, I like to write out all my steps, because something you could do is you could say, okay, g of 2 is -3, and then -3 goes to -8. Sorry. Why did I put 11? Oh, yeah, see, that's why I would make a mistake, because I would forget to look at f, and I would go down to -8. So I like to make sure I write every little step out so I don't make mistakes like that. Okay, let's try another one, part C. This time for C, the roles of F and G are reversed. You can see I have G composed of F. So I'm going to put G composed of F of 2. Now, something to notice here, the last one I did F composed of G of 2. This time I'm doing G composed of F of 2. And no, they're not necessarily going to be equal. And let's see if that happens here. So remember what this is. We're plugging in 2 into F, and then we're seeing where that value is sent by G. So first we find 2. 2 is sent to 1. So now I'm going to say that this is equal to G of 1. And I'm going to zoom out a little bit so I can see all this information here. And then I go to 1, which is right here, and I see where G sends it, which is 0. And as you can see here, when I did F composed of G of 2, I got 11. But when I did G composed of F of 2, I got 0. Okay, let's erase this and try D. Maybe you should pause the video and try D and see if you get the same thing I get. Okay, so this is part D, which is G composed of F of 3. Let me erase this and see what happens. So again, this is G with F of 3 plugged in. So I look for 3. I see where F takes 3, which is -1. So this is G of -1. I'm writing -1 there instead of this F of 3. Then I find -1, and I see where G takes it, which is 0. And that's our answer. So G composed of F of 3 is equal to 0. Now E and F are a little different. Let's see if we can figure these out. E is G composed of G of 1. Okay, so this is G with G of 1 put inside it. Okay, so let's find 1. 1 is right here. Where does G send that? G sends it to 0. So this is equal to G of 0. And then we find 0 and see where G sends that, which is 1. Now, it just so happened that we ended up getting the same number here, but that's not always the case. Okay, so we need to keep that in mind. Let's see what happens when we do part F. So part F is to find F composed of F of 3. Okay, so we start with 3. We plug it into F. Whatever we get, we then plug it into F again. So here's 3. When we plug it into F, we get -1. So this is F of -1. And then we take that -1 and we plug it into F. And you see we get 7. So here, we didn't get the same thing. We didn't get 3 again. So F composed of F of 3 gave us 7. All right, so we did this example. Now I want to do a visual, like graphing example. I mentioned that we can graph all of these points on the XY plane. Well, we also can graph infinitely many points. So that's our next example here. Here I've given you a graph. You can see it right here. This function, let me zoom in a little bit. This function is G, and this function is F. And you can see that the domain for g here, maybe we can write it here. I'll do it in red. So this function, this curly function here is g. And remember what the domain is how far left and right you go. Maybe we can put that here. The domain of g, well, the furthest to the left I go is this point here, and the furthest to the right I go is this point. Remember, we're looking left to right. And the x values, remember the domain is the x values. This point here is -1. Okay, let's erase that. And then this last point, the x value is 7. Now let's talk about the domain of f. Now f is this like check mark looking graph. And remember, domain is how far left and right you go. So we go from -1 all the way out to 8. That's the furthest point to the left and the furthest to the right. So -1 to 8. And notice that I'm putting brackets on these because we have solid colored in points here. Now, if these were open points, we would put parentheses on our x values. We could also talk about range. So the range of f, I started with g, so maybe we should stick with g. The range of g, and we can talk about the range of f. Now remember that range is how far up and down you go. So for g, if I look at this function here, ignore the one on the bottom, the furthest point downward I have is this 3, 1. And remember, the range is the y values. So the lowest y value you're going to have is this 1 here. So maybe we can say 1, 2. And how far up do we go? Well, this point here looks a little bit lower than these points here. It seems like the highest value I have is this 5. So it looks like we go from 1 to 5. And then for the bottom function, the lowest value I have is this point down here, which corresponds to this -2. And then the highest point I have for this function, if we go up, you can see that the last point I have is here. So we go up to 4. So that at least gives us an idea of the domain and the range. Now we're interested in composing these functions. Now I don't have every single point listed on these functions, but I have specific points. And what I'm going to do is I'm going to plug in specific x values, and then they're going to give us a y value. And then I'm going to take that value and I'm going to plug it into my other function. So this is very similar to the chart, except for as a visual graph example. So let's start with part A. Let's do this in a different color. Let's put it in green. So part A wants us to find G composed of f of 1. Okay, so again, I'm going to write out what this actually means. We're taking f, we're putting 1 inside it, we're seeing where that is sent, and then we're taking where that's sent and putting it inside G. Okay, so let's find f of 1. So the domain is the x values. So here is 1, and you can see that 1 is being sent to 4. So this is equal to g of 4. So now let's see where 4 is being sent. So we're looking at our graph. Oh, I think I got these two functions mixed up. I'm sorry about that. Let me try that again. Sorry. Again, this is right, g composed of f of 1, but I thought that the top graph for some reason was f. It's not, so let me fix that. F of 1, so we start with f of 1. It's the same idea. This is the function f. So 1 is being sent to -1. So this is going to be g of -1 because 1 is sent to -1. So I'm crossing this out and putting -1. Now I'm going to go to the function g, which this is the function g, and I look for -1. So -1 is right here, and it's sent to 3. So that tells me g composed of f of 1 is equal to 3. Okay, let's try another one. So the next problem, let me cross this out because we've done this one. We're going to do G composed of f of 5. So I'm going to erase this number here, erase all of this. And I'm going to put the number 5 here because that's what we want to find. Let me erase this stuff. Okay, so what we do is we plug in 5 into our function f. Again, here's the function f. 5 is the x value. When you plug it in, you get 1. So I'm going to put 1 here, and then I'm going to see where 1 is sent by G. So here is the x value 1, and 1 is being sent to 4. So G composed of f of 5 is equal to 4. This is part B. Okay, so we've done part B. Now let's try part C. Maybe you should pause the video and see if you can do part C and part D, and then just check and see if you get the same thing I get. Okay, part C says f composed of G of 0. Well, that's f with G of 0 plugged in. So I need to see where 0 is being sent under G. Okay, so 0 under G okay, so here's 0. The point's not listed here, but we can guess. So we can say that G of 0 is, it looks like it's about 5. This point looks like 0, 5. So this is f of 5 because 0 is being sent to 5. Remember, the y value tells us the function's value at that x value. And then we look to find 5 on f. Here's f. Here we can see the 5 in the x value, and the 5 is being sent to 1. So this is equal to 1. So f composed of G of 0 is equal to 1. So we did that one. Now let's try the last problem, part D. And what we want to find is f composed of G of 2. So let me erase this stuff. Okay. G of 2, that's where we start. So G of 2, let's find 2. Here's the x value, that's 2. 2 is sent to 2. So then we're plugging in that y value 2. And then we look for f, which is this check function. We find 2. Here's 2, the x value, that is sent to negative 2. So f composed of G of 2 is negative 2. Now you could put this in a chart like the last example, but you don't have to. You can just look at the graph. So the next thing we're going to do is I'm going to actually give you functions that are like an equation for a function. And then we're going to find f composed of G, G composed of f composed of f, G composed of G. We're going to state the domain of each of these functions. And then we're going to find something very similar to what we were doing in the last couple of examples. So we're going to plug in values. So that's what we're going to do in the next video.